Hey guys, welcome back to the second part of this video. We were talking about how I created my NFT Marketplace. In the first part of the video, I showed you the entire workflow of the app, how everything is supposed to work. I showed you how to create an NFT collection on my site, how to maintain new NFTs, how to buy and sell, how to make use of Woofy NFTs to decrease the market commission rate. So that was all about the functionality. In this part of the video, we're gonna go over the source code and how I coded it out. I'm a front-end developer. If you didn't know by now, if you're a first-time visitor, and recently I've been learning blockchain development, and I created this on Polygon. So over this video, I'm gonna talk about how I did that, but we're not gonna go line by line over the code. I mean, I think anyone can write code. The thing is, you need to understand the entire structure of the code. If you understand and create a structure, anyone can code. The main thing to do is to think. So I'm gonna go over my source code and just tell you about the entire structure. So let's get started. In my last video, I just created this new contract right here, and if you go to Polygon Mumbai and Polygon scan for Mumbai, you can see that the transaction indeed happened. We have a hash for it and whatever. So we're gonna go to the source code now. So in the first part of the video, I said that I hosted this on Versa. By the way, these videos are not sponsored by Vercel. I mean, I wish it was. I love Vercel, but no, these are not sponsored by Vercel. But still, I use it and I love it a lot. If you're using Next.js, you have to use Vercel. Vercel simplifies the process of deploying a Next.js server. You basically just host your code on GitHub, import it here, and with a click of a button, it deploys if your code is correct. So I'm gonna go to my GitHub and just do a run over of the code. Now, when you visit this this repository here, there's gonna be a README that contains links to part 1 and part 2 of the video and some pictures maybe. Currently it doesn't, but when you see it, you will see the README. Anyways, so this has two subfolders inside it. One for the client, that is the Next.js. The other one for the contract, which is using Solidity. So let's go over the contract first. And like I said, the way I'm going to do this video is give you an overall view. I'm not going to go line by line. And I'm just going to show you how I started doing that. So I'm using Hardhat for my local development environment and Solidity for the language for smart contract development. So initializing a Hardhat project is very simple. You just download the Hardhat package, use some package manager. I'm using PNPM. It's awesome. And if you don't know what PNPM is, well, it's just like Yarn and NPM, a package manager, but it's much faster, and its most useful feature is that it caches the packages. So any package that you use again and again, if you use Yarn or PNPM, it would download those packages before using them, even if you use that on some other project locally. So say for example, you're using Chakra-UI on 3 different projects. If you create 3 projects 3 times, it's going to download Chakra-UI 3 times. But if you use PNPM, it's going to download it only once and cache it somewhere. But that was a big speech about PNPM, and it's not sponsored by anyone. So anyways, so initializing a project with Hardhat is real easy. PNPX Hardhat, you're done. I think it's called Hardhat init, the command, and it takes you to a wizard. You fill in the details and a sample project is generated for you. You can delete the scripts that are there, and then you can create your own. So I write my own tests, my own deploy scripts, and my own contracts. Tests and deploy scripts, I'm not going to go over those. I think you can figure them out on your own. The code is here in my repository, so you can come and see that anytime, but I'm going to talk about the structure of the thing. So as you can see here, there's 3 contracts that are like deployed on the chain. 3 kinds of contracts. The first one, the simplest one, is the Woofy ERC721 contract. So I'm using OpenZeppelin library for all the implementations. So you have the URI storage for storing metadata. You have the enumerable for enumerating, because I need to enumerate all the tokens to see which one is owned by whom, because I need to show them on the UI, right? So I'm using enumerable. I'm using ownable because, well, only the author should be able to change stuff. So I'm using this as an access control. counters for the token ID because every token ID has to be unique, base 64, and that's because all the metadata that I'm storing, I'm not storing them on IPFS. I am encoding them in a base 64 format and directly storing them on the contract itself to minimize the usage of any other external platform, although I'm using IPFS to store the images. Strings, probably I'm using that for converting numbers to strings, and utils, where I have some set of utilities. So yeah, the way that this works is that any ERC721 would work. There are functions that you can use to create or mint an NFT. There are certain conditional checks here. I'm using max number of woofies to limit the number of woofies. If you saw the first part of the video, you'll know what I'm talking about here. And then you need to pay a certain amount of matics to mint and have a woofie to your name. And more checks, then the minting. And then I'm doing something, but I'm an idiot when I was doing this because this project took me 2 weeks to do. When I was writing this code, this part of the code here, I was in probably my first few days of these 2 weeks. So I didn't exactly know how you could return values from Solidity functions. It sounds very weird, but hear me out. Solidity doesn't allow you to return values from functions that are not view or pure functions. What it means is that if any function is changing the state of your contract, your storage state, then it doesn't return any, I mean, it does return anything, but the front-end library cannot process that. So the way you do that, the way I know right now, is that you fire events and you fire whatever you want to return in those events, and then on the front end you listen to those events and then you get that value. So that's how people should do, but that's what I didn't do here. I did that on the marketplace contract, which I'm going to show you. But the way this works is that imagine that I have that's my phone. Imagine that what I'm doing is that I need to mint an NFT and I need to set a metadata for that NFT, and you cannot do the same these two simultaneously. I mean, you could do that. When I was doing that, I didn't know how you could. So what I did here is kind of a hackish way of doing it. First, I'm creating the NFT. If the NFT gets successfully minted, what I'm doing is that I'm storing a mapping of your address with what token you just minted. So I know for a fact that which of the tokens does not have a metadata that just got minted, and I also have a cooldown period to ensure that, well, if a token was not given a metadata, then no one else could and this cooldown period, all it does is that it ensures that if a token did not have a metadata, then you're not okay, I'm just thinking of words to explain this. I mean, it's a really hackish way of what I did here. Think of it as you cannot create the same NFT again and again before cooldown period expires, or you gave a metadata to an incomplete NFT. Incomplete meaning that it doesn't have a metadata, it only got minted. So if you see this create NFT function here, you can only see mint, you don't see set token URI. You see the set token URI here, which means that you can only set token set URI on tokens that you create here. And to store that information, we're using this structure right here, this one. See this? This is a mapping that stores addresses and points to token IDs, and you can only set URIs and token IDs that are actually incomplete. And you also have the cooldown period. So if you have a pending NFT, you need to fix that before creating a new one, like I said. So that's why you have the cooldown period. It's a very hackish way of doing it. If I knew how you could return values from functions, I would have taken, who the hell is sending me messages? That's for Sam. Like I have anyone to text me. Okay, that's so sad. Okay, okay. So you don't do this. You use events to return, but more or less that remains the same. Whatever. Let's moving on. you merge some strings. Here I'm dynamically creating the URI. I have the image URI that gets uploaded to IPFS, and the URI comes here, which I then merge with a preset JSON string for name, description, and stuff. So and then these are just functions for enumerating. So all of these are view functions. From here you get all NFTs owned. Okay, this is not a view function, by the way. You are putting an NFT for sale. There's function for that. You are canceling, you are buying, and all of the data for the NFTs, like which NFT is on sale and for how much value, is stored inside this structure here. And the structure is actually a map that takes your token ID and points it to a structure, a Woofy cell info structure, that if you scroll above you could see inside this code. You have status and price, and the way I'm doing this is that if you have a mapping of any token ID, it means that it's for sale. If you don't have the value inside the mapping, it means that it's not on sale. So that's how I'm managing this. I remember I got stuck in this little approval part here because I didn't properly understand what approve was. Approve is something that you do to anyone who is supposed to perform the transfer of token when a purchase is made. So I am approving the contract address, the contract itself, to allow the contract to transfer the token on behalf of the owner, that is whoever invokes this function, to transfer it to the new owner, that is a buyer. So if you look at the buy function here, I got stuck in this part for like quite some time, a few hours, trying to understand how this is happening. Because what I did was I approved this here, and then I called safe transfer, not this dot safe transfer, but safe transfer from. And the problem it caused was that the the put for sale function was called by the seller, right? So the owner is calling the put for sale, but it's not the owner who calls the buy function. It's the buyer who calls the buy function, right? So since the buyer is calling the buy function, you cannot call this safe transfer from, because the caller is not the owner. And although the contract was approved to transfer the token, this function, if you write it in this way, you are telling Solidity to invoke it on behalf of the caller, not on behalf of the contract. The contract is approved, not the caller, which in this case is the buyer. It took me some good amount of time before I ended up on Stack Overflow, and I saw that if you use this dot any function name, what this does is that it invokes a function on behalf of the contract, no longer on the behalf of the caller. So this is how I fix this. I think you should know this. I wasted quite a few hours on this, just this one line. And these are just view functions. Get all NFT tokens for sale, whatever. And these are functions I had to override because ERC721 enumerable and storage both have these functions, and ERC721 also have some of these functions in common, so you have to be careful on how you override these methods. So that's it for the Woofy. Let's go back. Utils just has a few utilities stuff, you know, to combine strings. Maybe, yeah, I have a string count function that does this for me. The marketplace and the NFT contract, and this is the meat of the actual app. The marketplace, I'm not going to go line by line over this. You have a few events that are fired, and okay, this is something I should talk about. A create NFT contract, and this is the actual part of the marketplace contract that contains the meat of the functionality. That's the, I think, a bit difficult to wrap your head around if you don't know how it works. So how a create NFT contract works, I mean, you could either do this in something called the traditional way of doing it, where you deploy an actual ERC721 contract and it stays on the blockchain, and that becomes your new NFT collection contract, and then you interface with it to buy, sell, mint, whatever. The problem with that approach is that ERC721 contracts are quite huge in size. I mean, these are quite complicated contracts. So it's quite large in size. If people need to deploy big contracts every time they want to create a new collection, it makes things difficult because you're paying too much in gas fees. No matter which blockchain you are on, that's quite inconvenient. So you don't want that. So you don't do it in the traditional way. You do it in something called the minimal proxy contract. Just one Google search will show you what minimal proxy contract is. Minimal proxy contract, and I think it's called ERC 1160. Yes, it's 1167. And let me draw and show you what it does. Back here to GIMP. Yeah. Okay. So in a traditional way, what would happen is if you had, let's assume this is the marketplace. I am labeling this as M. If you, in the traditional way, what you would do is that you would deploy an actual ERC 721 contract on the blockchain, and you would use this contract to buy, sell, or mint your NFTs inside this collection. However, the minimal proxy contract, where what you do is that you have a single implementation contract deployed. What an implementation contract is that all the contracts, all the ERC 721 contracts have common functionalities, right? I mean, look at my app, for example. Yes, we do have many collections, so we have many different NFT contracts, but they all work in the same way. They all list things the same way. They all sell things the same way. They all track things the same way. Their codes are identical. Only the states are different, but their code is identical. So it doesn't make sense to deploy the same code over and over again, where all that's changing is just values. So what minimal proxy contract does, what the 1167 standard tells you, is that instead of deploying new contracts every time, you deploy a contract once, and then every time you need to create NFT collections, all you do is deploy something called, I'm going to use another color here, let's use orange. Okay, and you deploy something called a minimal proxy contract. Now the name has the meaning of what it does. I'm going to use small m. Yeah. What a minimal proxy contract does is that it behaves as some other actual contract. So this minimal proxy contract will behave like an ERC 721 contract, but it will maintain its own state. So all the state variables you have, the values of them will be owned and stored and manageable from here, but the code that this contract will run on is the code that is here. And this contract is relatively much smaller in size than the actual ERC 721 contract. So how does this happen? Well, it's simple. When you send a request to, and by the way, this is the address that you would share to people and tell them that this is my collection, come watch this. You won't share the address of this, you would share the address of this. Shit. Okay. So what you would do is that you tell your marketplace to interface with this contract, and there's an opcode in Solidity known as the delegate call. What delegate calls do is that it delegates, or it transfers the execution from itself to some other contract. So it transfers the execution from here to, say, here, and then it executes stuff line by line here. But the thing is, the state variables are taken from here. So you won't actually be modifying any state variables here because they don't exist here. They exist here. So if any code here changes state variables, they're actually changed here. So when the function execution is over, you have the state variables that are changed over here. That's the way I did my code. That's the way the minimal proxy contract workflow works. And it's quite amazing. When I first learned about this, it was amazing. And let me show you how you can do that. If you go to Open Zeppelin, I have it in my bookmarks. Bookmark always. And it's version 4. There's a search bar here, whatever. 1167, also known as the, where is it? Give me a moment. Yeah, it's called proxy. And so proxies, as it says, are just contracts that can implement proxy. A proxy is something that transfers, that acts as behalf of something else. That's the literal meaning of the word proxy. There is a clones library here, a minimal clone. You can import the clones, and what the clones library allow you to do is to give you functions that you can directly use to deploy minimal proxy contracts, given you have the address of an implementation contract. So watch this. The clone function inside the clones allow you to do that, and the way I did it. So what you do is call clone function, and you pass in the address of the implementation, which means you pass the address of this blue contract here, the C. That is the implementation contract, the contract that holds the actual source code. So you pass it here, and what you get in return is the address of a new minimal proxy contract. So the return value of clone function would be the address of this right here, which you can then store, and make sure you do store that, because if you don't store that, the address of that is lost forever unless you come and verify the transaction. So yeah, you clone, and it gives you an address of the instance, like I said. So it gives you an address of the new contract that Solidity itself will deploy, a minimal proxy contract that it will deploy, and then it will give you the address of. So that is one of the main part of the marketplace code. If you see the create NFT contract here, you see the clone function being called. Also note another thing. When you talk about this contract here, any contract will have something called the constructor code. The constructor code runs at build time as opposed to any other code that runs at runtime. The difference between the two is that runtime code runs as many times as someone invokes a function on it, but constructor code runs only when the contract is getting built, deployed. So constructor code, think about this. Any constructor code that is in the blue contract is supposed to be run every time this contract runs, right? But delegate calls cannot run constructors because constructor code is not included in runtime code. Only runtime code is deployed, not the constructor code. So if you have constructor code for the blue, it will never run. So if you are using constructor code for anything, it will never work inside this yellow minimal proxy contract. What you need to do is to use something called the initializer. In an initializer that is also available on the Open Zeppelin, all it does is that in place of a constructor, it allows you to run the constructor code in runtime code by using a separate function that is included in the runtime code but is only executed once. So the way you do that is, well, let me take you to Open Zeppelin again. And instead of using standard libraries, ERC721, instead of using the ERC721 right away, what you do is that you use, okay, let me just search for the name and see if it pops up. Hold on. Where did I put that? It's contracts upgradable. I always forget the name. So there are two kinds of contract libraries that Open Zeppelin has when it comes to proxying. One is the actual contracts library, which is Open Zeppelin /contracts, and the other is Open Zeppelin /contracts upgradable. And you need the upgradable versions of the library to be able to call initialize here. Where are all? Okay, I have too many tabs open. Let me just rearrange stuff. Hold on. Okay, so if you notice the NFT, which stands for the NFT implementation contract, which you typecast the address, and you run the initialize function, which behaves like the constructor because it needs these values to initialize, right? So if you look at the initializer code for the NFT, you see that the initialize function is indeed here, and it is using the initializer, what do you call that? Okay, what is the technical term? It's called modifier. Yeah, so you use the initializer modifier that restricts the number of times you can run this function for one, and all it does is that it does the job of a constructor. But if you notice properly, you also have these three lines here. Now what do they do? Well, if you're using constructor to initialize a contract that is derived from other contracts, well, then what Solidity does is that it runs the constructor of the parent contracts, and then it runs the contracts, constructors of the child contract. If you use the initialize function, however, there is no such functionality because it's not a constructor. So Solidity can't figure that out on its own. You're gonna have to do that, and the way you do that is, number one, you use upgradable versions of the contracts and not the actual ones, and number two is that you call these. Hold on, did okay, that's because it's inside enumerable. Yeah, keep forgetting what I did myself. Inside the enumerable NFT, what I'm doing is that I'm inheriting from enumerable, and enumerable in turn inherits from contracts upgradable here. So ERC721 URI storage, it inherits all of these from the upgradable contract suite. So it takes things from there. So that's why you have access to these three functions. If you read the documentation, it will be clear for you, although I agree that on part of OpenZeppelin, the documentation could have been a bit better. But I mean, gets the job done. So whatever. So you have the initialize function. You have to initialize these in the correct order, and well, now your contract is ready. When you do that, when you initialize the contract here and then you add to the collection, and now your minimal proxy contract is all deployed. After that, it's easy selling from here. You have functions to go through each of the contracts that you deployed and get views from there, each individual view. What I mean by that is functions like these, say get NFTs owned or get NFTs on sale or whatever. So it enumerates through all of that, merges them, and then gives the result on the front end. So that's how the contract side is working. Once you deploy that, the remaining part is the front end. So the front end is made with Next.js, and I'm using the Ethers.js library for interacting with my smart contract, and for UI I'm using Chakra-UI. And my favorite UI framework, UI component framework, was the Material UI till the day I found Chakra-UI, and now Chakra is my favorite. I'm gonna make a new video on Chakra-UI someday. And I think it's better than Material UI, and to discuss why, I'm gonna make a new video. And but that's a topic for another day. In this, let me show you how I went about with the Next.js. So it's quite simple. I'm using type chain to generate typings for my Solidity smart contract. So once you have the typings, paste them here, and well, you have TypeScript support now for every contract, which means you have fully typing support for all the contracts, the parameters it takes, whatever it returns, every struct, everything. You have typings for everything. So type chain is awesome. And I don't really know what I should explain, because Next.js, if you know how Next.js works, you can figure this out, how everything is working. Let me just show you the app, what it does. So you're a provider for Chakra. I have 3 different custom providers I have and the way I'm managing is that I have 3 different contracts, right? The Woofy contract informs the marketplace contract. The marketplace contract deploys NFT contracts. So I have 3 layers, and you see that I have a wallet provider here that has code that interfaces with MetaMask. I have the Woofy provider here that takes values from the wallet to the Woofy, and then finally I have the marketplace provider here that takes value from the Woofy. So I have 3 layers of providers. Yes, I could have used Redux here. I know, I could have used Redux over here. I didn't. I was lazy. But I should have. Here, that's the good way to go about this one. And if you are using React, you would be a fool not to use custom hooks. So I have tons of custom hooks, in fact. So, and when I say tons, you're going to see what I mean by tons. Let's take the use wallet, for example. The use wallet only uses the context from wallet.wallet context. So let's look at the context of what I have. So contexts, and I have 3 different contexts. Let's look at the wallet context, and you're going to see a huge code. Everything is a state that is returned by the context. So using the context gives you access to the states as well as the state setters. And I have a couple of functions that does stuff, that does connections, handle connections, show you toasts on your site whenever you log in. And I have tons of functionality here. And the reason I use custom hooks is that it simplifies the process a lot. With just one hook, use wallet, I can get access to all these three, all of these things, the provider, signer address, whatever. If I didn't use a custom hook, it would have been terrible to just paste all of this inside a component. The way React works, I think it's best to separate UI part from the functionality part. I keep the functionality part always in custom hooks or functions that I import from another file, and I keep the UI part in a different file, if that makes sense. So TSX files are only for UI, and I use TypeScript files only for custom hook functionality, which I use in turn for functions. That's how I do it, and it makes the code a lot more cleaner, easier to maintain. So that's what context is doing here. And contracts again contains the interfaces for all the contracts that got generated here. I'm using a lot of scripts I have. So say for example, if I open the package JSON for here, you're gonna see I have different build scripts here. I have a type chain that generates typings for the contract. And whenever I run the Next.js server, you're gonna see, where is package JSON? You're gonna see I have a long code that runs here, and all it does is that it compiles the contracts, copies the interfaces, pastes them here, and also pastes the interface, pastes the typings, and then it starts the dev server. So that's what happens here, and then it starts the dev server at the end. I had a lot of fun making this thing. I have frame emotion here, but I am not using frame emotion anywhere. I thought I would use it, but then I was so lazy I didn't even remove this. What the hell? Terrible. So anyway, that's how my the entire app is working. I made this video just to show a demo that how I did it. I could have done that in a much better manner, I think, now that I have made the project and it's deployed. I'm lazy, I'm not going to go over that again. But there's a conclusion that I find for this video. So I'm not going to drag this any further. I hope you liked watching this video. If you have anything to ask, please contact me on Twitter. I'm active there. You can send me a DM, tweet me, whatever, or comment down in the video. I am active everywhere, and I'll see you in some next video. It's 9:30 p.m. here. I'm very tired. Bye.